Good afternoon. I hope you are all doing well and you are getting ready for the test. I see that more than half of you still have not done the submission of the practice test. And I don't know why that is, because the practice test was on Saturday. Now all that is left is for you to upload it. So if you wait for Saturday to do it, the tutorial test will be closed and you might not have enough time to actually do it. So make sure you upload it as soon as possible. All right, so again, the test is on Saturday. I see most of you know how to upload. I looked at the uploads that those of you who did submit have uploaded, and they are good. Some were pictures, but that's fine as long as I can see everything. I shouldn't see your background. I should just see the paper. That's it. Okay. All right. So the test will cover everything from logarithms till where we end tomorrow. It's not a difficult test. It's pretty simple. Just study and you shouldn't have any problems. So try to start on time. You start at 6 o'clock. The test will close at 8 o'clock. And again, if you have not submitted by 8 o'clock, that means you have not written the test. So make sure you submit on time. Right, then today we continue with our inequalities. We'll look at a few word problems. And the thing about word problems is it is very important that you read them correctly. So you need to understand some of the terminology that we use in our word problems. So let's look at a few of those. Now, the first one is if I say 7 is greater than x. Okay, now we want to translate this using mathematical signs and symbols, that 7 is greater than x. This one is very simple to do. We just say 7 is greater than x. So your inequality should always face in the direction of the bigger number. So that's what 7 is greater than x looks like. The next one is 10 less than t. Okay, now 10 less than t, this means from t you subtract 10. So when I write this, this is t minus 10, because t minus 10 is 10 less than t. So that is how you would translate that one. Then another one, x is at most. You've noticed even from set theory, people struggled with at most and at least. So x is at most 5. How do we write that in mathematical way? Now remember what at most means. At most, that means your maximum. So the maximum of x is 5. It can be less than 5, but the maximum is 5. So this means that x is less than or equal to 5. So x is at most 5. And I say equal to because it can be 5. So if the maximum is 5, x can be equal to 5. And that is why I have the equal to there. Then the next one is x is at least 5. Okay, so if x is at least 5, that means 5 is the minimum. That is the least amount. Just like you say the least that you can do, that is the minimum that you should do. You can do more, but that is the minimum. So x is at least 5. This means that x is greater than or equal to 5. So these words, at least and at most, be wary of them, know how to use them. And then the next one, y is no more than 2. Okay. So when it is no more than something, that means it is not bigger than something. That is the most it can be. So when we say y is no more than 2, it means that 2 is the maximum. So this one, we say y is less than or equal to 2. So 2 is our maximum because y is no more than 2. Then next one, h is no less than 8. Okay, so no less than 8. This means that 8 is the minimum, so it cannot be less than 8. So it can be 8 going upwards. So this means that 8 is less than or equal to h. So here I can also write it as which is greater than or equal to 8. These are saying exactly the same thing. Because if 8 is less than or equal to h, it means that h is greater than or equal to 8. So that is just to illustrate some of the words that we use when we deal with word problems. So make sure you know what it means when we say no less than, no more than, at least that much, at most that much, and less than or greater than. Okay, so let's look at some of the examples where we use these. So these are questions from your notes. Along. Okay, now with this first question, we are told that Ali wants to rent a chainsaw. Now, in order to rent a chainsaw, there are some charges that he will pay. So to rent it, he must pay $15 upfront and then pay $2 for every hour that he rents it out. This is $2 per hour. Okay, so that's how much it costs to rent the chainsaw. Now, in the question, it says Ali can spend no more than $35. So he can spend no more than $35. Now the question is, what is the maximum amount of time he can use the rented chainsaw? So the first thing to do here is to understand what it means that he can spend no more than $35. So that means $35 is the maximum amount of money that he has to pay the rental company. So he cannot, his charges for renting the chainsaw cannot exceed $35. So he has to make sure, however long he uses the chainsaw, when the company tallies up how much he owes them, it should be less than $35. So no more than 35 means $35 going down. So what we do is we let x equal to the number of hours you can rent the saw for. Okay, so if x is the number of hours that he can rent it for, then his total costs, we know that his costs will be, first he must pay the $15 that is given, and then he must pay $2 per hour, and he is renting it for X hours. So this is how we will calculate his total cost. We say $15 upfront and then $2 for every hour. And how many hours do we have? This is X. Now we say that he can rent it, he can pay no more than $35. So this total cost should be less than or equal to 35. He has $35, so it can be equal to $35, but it cannot exceed $35. Now this is a simple linear inequality that we solve. This is 15 plus 2x. This is less than or equal to 35. And then we'll subtract 15 on both sides. We get 2x. This is less than or equal to 20. And then we will divide by 2 on both sides. So remember, when we divide by 2 on both sides, the sign does not change because 2 is a positive number. Only when we divide or multiply by a negative number does the sign change the direction that it is facing in. So X is 10, so that tells us he can afford to rent it for at most 10 hours. Anything above 10 hours, he will have to spend more than $35 and he cannot afford it. So his maximum time is 10 hours. So you answer that in a statement. You can word it a little bit differently. See in the notes, he says he can use the saw for a maximum of 10 hours. That is fine. So maximum of 10 hours, at most 10 hours, that is fine. And we look at another example. Okay, we are told that Sue earns 1.25% commission. So her commission, this is equal to 1.25%, but this commission is on sales above 10,000. And this is for sales that exceed 10,000. Now she wants to find out how much should she earn, how much must she sell in order to earn a commission of at least 1,500. So what she wants is a commission to equal to 1,500. So her question is, how much should she sell in order to make that commission? So what we do is we can let S be the sales amount. Okay. And then we want the commission to exceed 1,500. So we calculate the commission by saying C is equal to 1.25% of S. That is how we calculate her commission. And then we can rewrite this 1.25%. This is 1.25 over 100. Of in mathematics means times, so we multiply this by S. And we say that we want a commission of at least 1,500. So at least 1,500, that means we want this to be greater than or equal to 1,500. Then this is simple to solve. If S is greater than 1,500, you multiply by 100, and then you divide by 1.25. So you get S is greater than or equal to 120,000. Okay, so if her sales amount is that much, then her commission will be at least 1,500. Okay, then number 3, I'm on page 52, by the way, if you have your notes with you. Number 3, yeah, you have to write a statement. So you can write a statement to answer that. Just like I said, her sales must be greater than 120,000 in order for her to get a commission of 1,500. So with these word problems, your final answer must also be a statement. And then number 3, we are told that Tyra has test scores of 70 and 81 in her biology test. To receive a C grade, she must obtain an average greater than or equal to 72, but less than 82. What range of test scores on the one remaining test will enable Tyra to get a C for the course? So she's written 2 tests so far. So test 1, she got 70. Test 2, she got 81. And then test 3 is still pending. Now she wants to get a C, but we know that a C is like that. Okay, so if you have a grade that is greater than or equal to 72 but less than 82, then you have a grade C. So what she wants to do is work out how much should she get in test 3 so that the average of the 3 tests is between 72 and 82. So what she wants is this 72 less than or equal to 70 plus 81 plus x, which is test 3 mark, divided by 3 because it is the average, and then this is less than 82. So you can combine these two together, 70 and 81, you get 151. So you have 72 less than or equal to 151 plus x over 3. This is less than 82. Then you multiply throughout by 3. So say 72 times 3, you get 216. And then in the middle, when you multiply it by 3, the denominator will cancel. So if I multiply by 3, it will cancel. Multiplying throughout by 3. So I will be left with 151 plus x, and this is less than 246. Then I can subtract 151 from each of the regions. So I say 216 minus 151, I get 65. This is less than x, less than or equal to, this is less than 95. Okay, so if in the last remaining test she gets between 65 and 95%, then she will get a C for the course. So we write this as a sentence. More. but less than, you'll write it better, but less than 95%. Okay, so she needs to get a mark of 65% or more, but the mark should be less than 95. So if she gets 65, she is within the C grade. If she gets 95, she's no longer in the C grade, she'll have a B now, so it must be less than 95. We'll look at number 7. With number 7, we are given a rectangle. So this is what our rectangle looks like. We are told that the width of this rectangle is 22 meters, and we want the perimeter of this triangle to be at least 90 meters. So the perimeter be at least 90 meters, as well as not more than 120 meters. Okay, so those are the two conditions we have on our rectangle. So we want to make a rectangle. We know the width, it should be 22 meters, that is fixed. The length can vary as long as our perimeter is at least 90 meters and not more than 120 meters. So with this one, what we do is we write a formula for the perimeter. So before that, I can just summarize what I've written over there. This means that the perimeter P is between 90 and 120. That is a summary of what I have written over there. And then we know how to calculate the perimeter. The perimeter of a rectangle is 2 times the width plus the length. So this is the width, this is the length, this is the length. So if I start over here and I walk all the way around, the perimeter is just the distance around the shape. So I will have L plus W plus L plus W, which is 2L plus 2W. So perimeter, the formula is 2L plus 2W. Okay, now I know that the width is 22, so I will substitute that. So I have 2 times L plus 2 times 22. This is 2L plus 44. So this is my perimeter that I need to ensure is between 90 and 120. So I'll substitute it into the inequality I have over there. So I say 90, this is less than 2L plus 44, and this is less than or equal to 120. Now when we have inequalities like this, you want to isolate x in the middle and or everything else on the left or the right of x. Then you subtract 44. Subtract 44 in all 3 regions. So here you'll have 46. This is less than 2L. And this is less than or equal to, this is less than or equal to 76. And then you divide by 2 throughout. Divide by 2, divide by 2, divide by 2. And notice that my inequalities do not change directions because I'm dividing by a positive number. The inequality only changes direction if you divide or multiply by a negative number. So what I will have left is 23. This is less than or equal to L, which is less than or equal to 38. So if you build a rectangle where the length is between 23 and 38 meters, you will notice that the perimeter, if you keep the width as 22, the perimeter is between 90 and 120. Okay, so the width, sorry, the length Okay, so that is how you'd answer that one. The width should be kept between 23 and 38 meters in order for the requirements on the perimeter to be met. So you can phrase it how you think, but the idea should remain the same. And I want to do one more, number 13. Number 13, we are told that if A is less than B, can you show that A is less than A plus B over 2, which is less than B? So here, I think you can try it with any two numbers you can think of. So this, just to check that this is true. If I have two numbers, 2 is less than 4. If I add them, I have 2 plus 4, then I divide by 2. This is 6 divided by 2, which is equal to 3. And it is true that 2 is less than this 3 over here, and this 3 over here is less than 4. So we call this the arithmetic mean, this A plus B over 2. This is called the arithmetic mean. So if you have two numbers, you work out the average of the two. The average will be between the two numbers. It cannot be greater than both of them or less than both of them. Right, so now how do we prove this? So we have A less than B. Now we know that an inequality does not change direction when we add anything on either side. Now we don't know whether A or B are positive or negative, or one is positive, the other one is negative. We don't know anything about them except that A and B, A is less than B. So what we can do is we can add B on both sides. So if I add B on both sides, this is what I have. The inequality doesn't change because when I add anything on both sides of my inequality, the inequality is preserved. Now here on the left hand side, I have A plus B. On the right hand side, I have B plus B, which is equal to 2B. Then what I can do is divide by 2 on both sides. So I divide by 2, then I divide by 2. What I have left is this A plus B over 2. This is less than B. So you'll notice this is the first half of the inequality that I'm trying to establish, which is this one here. So it's this part. So I have shown that B is greater than A plus B divided by 2. Okay, so which is what I've done over here. So now I need to show that A is less than what I have over there. So I follow pretty much the same thing that I did. So I start with what I'm given, that A is less than B. Then this time I add A on both sides. So I have A plus A, this is less than A plus B. And the inequality doesn't change direction because when we add or subtract anything on both sides, the inequality is maintained. Then on the left hand side, I have 2A, this is less than A plus B. And then I can also divide by 2, divide by 2. The inequality doesn't change because I'm dividing by a positive number. So now I have both sides of the inequality. So I have A is less than the average, and the average is less than B. So I can write it. I say therefore, we say that A is less than this. And from the first one, we say that this is less than B. So you have shown it. So that's what it means when we say show or prove something. Okay, do we have any questions? Or are we fine? Okay, sounds like you're fine. I hope you really are. The next thing we look at is compound inequalities. Now, compound inequalities, these are like two inequalities that you must solve and then combine your answers. So these are connected with words like and or. So you'll see one inequality and another one, or it says one inequality or another inequality. Now the way we use and or here is the same way we did in set theory. And means it must satisfy both of the inequalities, or means as long as it satisfies one of them, that is enough. So if we look at an example, it says solve for x when we have 3x plus 2, this is less than 14, and 2x minus 5 is greater than minus 11. So we want an x that satisfies the first inequality as well as an x that satisfies the second inequality. So it must satisfy both of them. That's why we have and over here. So if it satisfies the first one only, that's not what we're looking for. If it satisfies the second one only, that's not what we're looking for. It must satisfy both of them. Okay, so we solve them, and then we will combine our solutions on a number line, and you should also be able to write this in interval notation. So if I look at the first one, so that's number 1, I have 3x plus 2, this is less than 14. We know how to solve this. You need to isolate x on one side, so I will subtract 2 on both sides. So I have 3x, this is less than 12, and then I divide by 3, divide by 3. When I divide by 3, the inequality doesn't change direction, because it only changes direction when I divide by a negative number. So I have x is less than 4. So this is the first condition that I will have to combine with the second one. Then equation 2 says 2x minus 5 is greater than minus 11. So again, we want to isolate x, so I will add 5 on both sides. So I have 2x is greater than negative 6, and then I will divide by 2 on both sides. And again, the inequality does not change direction because I am dividing by a positive number. So that is what I have, and I need to combine them. So I'm looking for a number that is less than 4 as well as greater than minus 3. So I can represent this on a number line. And I put my numbers minus 3 and 4. Okay, then x less than 4. That means on top of x, my circle is unshaded because this is not equal to. It cannot be equal to 4. It must be strictly less than. And then all the numbers less than 4 are in that direction. And then for the second one, x is greater than minus 3. So on top of minus 3, my circle is unshaded, and the numbers that are greater than minus 3 are to the right of minus 3. Then I pretend I'm standing here on the number line and I look up. The region that is a solution to my problems is the region where when I look up, I see two lines above me. Now, if I am standing somewhere here and I look up, I only see one line. So that is not fulfilling the end condition. So it's only for the first one. If I'm standing over here, the same thing is true. It is not fulfilling the end because I only have one line above me. But if I'm standing anywhere here, and I look up, I will always see two lines above me. So my solution will come from, or my solution will be all the numbers between minus 3 and 4. So I can draw my number line. This is what it will be. I have minus 3 and I have 4. Put open circles because the circles are open over there, so it cannot be included. And then you connect the circles with a line. And you can also write this in interval notation. We said open circles means round bracket. That means negative 3 is not included. And then 4 and another open bracket, round bracket, because 4 is not included. So this first one here is representing it on the number line. This is interval notation, and you can also rewrite it, write it like this. That is also fine. So depending on how you're asked to write it, you can write it in set builder notation. You know how to do that. Okay, so that is a compound inequality. It must satisfy both of them. If it says and, if it says or, as long as it satisfies one of them, then that is what you are looking for. Let's look at x plus 1. This is less than or equal to 9, and x minus 2 is greater than or equal to 3. So I do the same thing. I will solve the first equation, the first inequality, solve the second inequality, combine them on the number line, and then give my final solution. So x plus 1 is less than or equal to 9. This means that x is less than or equal to 8. So that is the first one. Then for the second one, I have x minus 2 is greater than or equal to 3. This means that x is greater than or equal to 5. So here, these two are connected by an and. So that means when I look up and I'm standing on the number line, I must see two lines above me. So I will draw my number line. I'll put the points. I have 5 and I have 8. Then less than or equal to 8, the circle is shaded because 8 is included, and less than means to the left of 8. And then greater than or equal to 5, my circle is shaded because 5 is included. And then greater than 5 means to the right of 5. So again, I see where do I need to stand on the number line so that when I look above, there are two lines. It is in this region over here. So anywhere there, when I look up, I will see two lines above. So I can draw the number line solution. This is what it will look like. I put the 5, I put the 8. The 5 is shaded because it was included there, so it is on both lines. The 8 is shaded because it's included in the first, the one above, and it is on the line below. Then I connect them using a straight line. Then in interval notation, in the square bracket means it is included, comma to separate them, the other endpoint, and then also a square bracket because it is included. That's how you would write it. Now we can look at one with OR. We have minus 4x plus 1. This is greater than 9. Or 5x plus 3. This is less than or equal to minus 12. So we have those two. Now with this one, what we're looking for when we're standing on the number line is when we look up, we must see a line. So if I look up and I do not see a line, that is not what I'm looking for. So I'm not in the correct region. So let's solve them and see what I mean. The first one, I have minus 4x plus 1. This is greater than or equal to 9. Then I will subtract 1 on both sides. So I have minus 4x. This is greater than or equal to 8. And then I'm going to divide by negative 4 on both sides. So when I divide by negative 4 on both sides, the inequality must change direction. So I have x, and then you see my inequality has changed direction. It was the greater than or equal to inequality. Now it is the less than or equal to inequality. And then I have 2. So this is the first one. Then I solve the second one. I have 5x plus 3. This is less than or equal to minus 12. Then again, I will subtract 3 on both sides. So I have 5x. This is less than or equal to minus 15. And then this time when I divide by 5, the inequality does not change direction. So I have x is less than or equal to minus 3. So these are my two solutions for each of the inequalities. Now I draw them on my number line. So I have x is minus 3. And x is minus 2. So minus 3 comes first in the number line. Then the first solution, we said x is less than or equal to negative 2. So I have a circle that is shaded because it can be equal to negative 2. Then I'm going in that direction because that is where the numbers that are less than negative 2 are. And then at 3, negative 3, my circle is also shaded because I have less than or equal to. And I want the numbers less than, they're on the left. Okay, so what I said is with OR, what I'm looking for is when I stand anywhere on the number line and I look up, I must see a line above me. So it doesn't matter if it's 2 lines, as long as I can see a line above me, then that is a solution. Now if I'm standing in this region here, numbers that are greater than negative 2, when I look up, there's no line above me, so that is not a solution. In this region, from minus 2 to negative 3, I can see there is a line above me, and then minus 3 to infinity, there is a line above me. So there must be at least one line above, then it is a solution. So here the solution will be this area, everywhere where there is a line above. So you can draw this. You have minus 2 here, shaded circle going that way. And in interval notation, so these are the numbers that start at minus infinity up until -2. Remember, minus infinity is never included. So we have minus infinity. Use the symbol. I'm thinking I'm on e-learning. Okay, that's minus infinity, and then -2. Here I have a square bracket. So infinity and minus infinity are never included. You never include them. When you have infinity and minus infinity as your endpoints, you must have a round bracket. Putting a square bracket is wrong. You must have a round bracket. So that is how you would do it in interval notation. This is the same as saying x is less than or equal to -2, which we got from our solution. Let's look at another one with or. We have 6x minus 4. This is less than 2x, or negative 3x is less than or equal to -9. So that is what we have. And it says we must graph the solution set. So when it says graph the solution set, that means you represent it on the number line. So we start with the first one. We have 6x minus 4. This is less than 2x. So you want to collect all your terms with x on one side, everything else on the other. So I will add 4 on both sides and then subtract 2x on both sides. Then I will have 4x. This is less than 4. Then you divide by 4. You get x is less than 1. We have x is less than 1. That is your first solution. Then for the second one, look at minus 3x. This is less than or equal to -9. So here, the terms with x are already isolated. So the only thing to do is just divide by -3 on both sides. And remember, when you divide by -3 on both sides, the inequality should change the direction it is facing in. So you'll have x is greater than or equal to +3. So you have your two solutions over there. So to represent them, you draw a number line. The first one was that x is less than 1, so 1 will appear before 3. So our circle is unshaded because it is strictly less than 1, and less than 1 is to the left of 1. And then x is greater than or equal to 3. Greater than or equal to 3 means our circle is shaded, and greater than 3 means to the right of 3. So again, you walk along your number line and you ask yourself, where do I need to stand on the number line so that I have a line above me? I can see at least one line above me. Now, if I am standing in this region, I can see a number line above me, so that will be a solution. If I am in this region over here between 1 and 3, I do not see any line above me, so that is not a solution. And over here, there is a line above me, so that is a solution. So on a number line, it is just the way I have it over there. So I have 1, and then I have 3, circle unshaded, going that way, circle shaded at 3, going this way. And then in interval notation, what we do is we'll use the union. Remember what a union of sets means. You combine all the elements, put them into one big set. So this first set over here, call it A. When I write it in interval notation, it goes from minus infinity. Remember, minus infinity is never included. That's why I have a round bracket. And then ends at 1. 1 is not included because my circle is unshaded. So I put a round bracket. And then this set over here, B, it starts at 3. 3 is included. That's why I have a square bracket. And it ends at infinity because it just keeps getting bigger and bigger. And infinity is never included. That is why I have a round bracket. And we say this is a combination of the two sets. It is the union of the two sets. So that is your solution in interval notation. Okay, so we say that these two sets are disjoint. So remember those terms we used in set theory. Disjoint means their intersection is empty. There is no number that is in set A as well as in set B. And some more examples. Look at the exercises that are in your book. This is page 56. Let's look at number 1A. So we have x plus 5. This is less than or equal to 11. And x minus 3 is greater than or equal to minus 1. So that is what we have. Then we solve them just like we did, keeping in mind what and means. And means when I look up, standing anywhere on the number line, I must see two lines, or means one line is fine. So the first one, I have x plus 5. This is less than or equal to 11. This means that x is less than or equal to 6. So I subtract 5 on both sides. This is the first solution. Then the second one, I have x minus 3. This is greater than or equal to minus 1. I add 3 on both sides. Again, x is greater than or equal to 2. So here are my two solutions. Then I will plot them on the number line and put the numbers. I have 2, which comes before 6. And then at 2, my circle is shaded because I have greater than or equal to. So I want numbers that are greater than or equal to 6. That means, sorry, to 2. That means it is on the right of 2. And then at 6, my circle is also shaded because I want numbers that are less than or equal to, and less than means to the left. Then again, you walk on the number line looking for the area where if you look up, you will see two lines, and that is in this area over here. So you can draw the solution number line. So you have 2, you have 6. 2 is shaded because it was shaded in the first line. 6 is shaded, was shaded in the line above, and you connect them. Then in interval notation, you have a square bracket because 2 is included. You separate them by a comma. 6, also a square bracket because 6 is also included. Then we do one more. X plus 2 is greater than 7, or 1 minus x is greater than 6. So we solve the first one. We have x plus 2. This is greater than 7. This means that x is greater than 5. So I subtract 2 on both sides. This is my first solution. And I have 1 minus x is greater than 6. So I will subtract 1 on both sides. So I have minus x. This is greater than 5. And then I will divide by negative 1 on both sides. And then when I divide by negative 1, the inequality changes direction. So I have x is less than negative 5. So these are my two solutions. Go to my graph and put minus 5 here, and 5 is somewhere over there. And the first one, I want numbers that are less than -5. So my circle is not shaded because 5 is not included. I go in that direction. And for the second one, 5 is also not included, and I go to the right. So my solution set is just as I have drawn it. So when I look up over here, I will see one line. That is what I want. When I look up over here, I will see a line above me, which is what I want. But in this region over here, if I look up, I do not see a line, so that is not a solution. Then I can write this in interval notation. I have -5 and 5, and both my brackets are round because neither 5 nor -5 is included in the solution. Okay, so there are more questions to look at in your notes. The procedure is pretty much the same. When it's and, anywhere on the number line, you must see two lines above you. And if it says or, you just need one line. One line is enough. If there's two, great, but one line is enough. Okay, do we have any questions before we go about the test? Is there anything that is not clear?
Miss,
Yes.
do we need graph paper for the test?
If you will have to draw graphs, then yes, you will need graph paper. But if you don't have graphs, then block paper is fine.
Oh, Miss, I was just asking because I don't have graph paper and I'm at the village. So I just needed to know a bit earlier.
You can go and get some now. Can you not? If I tell you you need graph paper now, will you be able to get it?
I'm
So
not sure, Miss.
if you have to draw graphs, please use graph paper or block paper. That's because you need to read the graph. So if you
Yes.
just have a plain paper, I don't know how you'll be able to read that this is the point. You'll just be guessing, I guess. Yes. Somebody
Miss,
else said it. Yes.
can you please cancel the class for tomorrow so we study for the test?
I already canceled the one on Tuesday. What were you doing on Tuesday? You didn't study that day. We have to finish
It's a
this
lot of things.
because like I said, the test will cover everything we have done until the end of this week. So we need to have class tomorrow.
Yo,
It's not a difficult test, so don't worry.
yo.
Not at all. So we need to
Okay,
have
Miss.
class tomorrow. Yeah.
Miss, can you please? Sorry, Miss.
Yeah.
Miss, can you please do me a favor and just scroll up? I just missed some. I just missed one equation that I have to take note of.
Let's see. There.
It's no.
Let's see more.
I think it's the one that is of 5x plus 3. It's the one above, Miss.
This one. Is this
The
one number
question,
3?
the third one, the third example.
Is that the one?
Yes, Miss, I think so.
Okay.
Yes, it's this one, Miss.
Is that fine? Or I should scroll down?
No, I'm fine here, Miss. I just wanted to write this for x plus 1 like that. I
Okay.
missed it somewhere here.
Okay.
Ma'am,
Yes.
Ma'am,
Yeah.
why aren't you using infinity in the last example?
Which last example? Why aren't we using infinity? Let me see.
Yeah.
Yeah, it's true, it's true, it's true.
Yes, I think I'm tired. Sorry, guys. That is true. So this solution is like this, and then it should be the union. That is true. Very important. Thank you very much.
Mm.
Okay.
Ma'am,
Yes.
when you said the test will be everything that we have done, do you mean from the beginning or from where we started this?
No, I think I said from logarithms.
Oh, okay.
Yes. Okay, if there are no more questions, have a good day. Don't worry, the test is very simple. Just start on time and upload before 8 o'clock because it's really a simple test. So if you miss this one and now you must write the supplementary which covers everything, that will be very, very difficult. Okay, so have a good day.